Welcome. Today I'm excited to present Grounded, the Localizing Ground Penetrating Radar Evaluation Dataset. Grounded aims to address the localization problem. In order for autonomous vehicles to navigate, they must have a way of localizing in their environment. Since GPS is not accurate enough, most autonomous vehicles use onboard sensors to precisely localize in HD prior maps. Now, the most common sensors used for this are LiDARs and cameras. However, both of those face challenges. For example, if snow is covering this road, a LiDAR sensor won't be able to view the lane markings that are recorded in its map. Localizing Ground Penetrating Radar, or LGPR, has been proposed to address this issue. You can see the LGPR sensor hanging off the back of this Prius. The LGPR sensor uses radar to record the underground topology up to 10 feet below the road. This means the map is completely underground and much less likely to change than surface maps. Now this is the LGPR sensor. Across the bottom there are 12 radar elements, and their signals are collected in the switch matrix. They are then sent to the processing chassis where they get compiled into LGPR scans. The GPS is used to label each scan with the geographic coordinates where that scan was recorded. In our prior work, we showed that we could enable autonomous navigation using only an LGPR sensor. So the car is piloting itself, but what's cool about this ride is that the vehicle can't see the road at all. It has no cameras or LiDAR sensors. Yet it's able to follow this snow-covered road by tracking the underground map. However, there is a problem. There's very few existing LGPR sensors, and the ones that do exist are very large and expensive. This makes it really hard for researchers who want to develop new algorithms. Now, luckily, several companies have announced plans to commercialize this technology and collected millions in funding, which is really great, and we hope soon you'll be able to purchase an LGPR sensor as easily as buying a camera. However, currently, these sensors still have to be custom built and they can't be bought. To make it easier for researchers to get into this exciting new area, we're releasing Grounded. This is a data set that includes 108 individual runs with more than 450 kilometers of driving. Each run includes LGPR scans, as you see in the bottom right, along with RTK GPS for ground truth, which gives the location, the geographic coordinates of each scan. We also have camera and LiDAR streams, which will allow you to compare this modality to the current state of the art. Finally, we also include a variety of environments and weather conditions in the dataset. We've selected two benchmark areas to highlight where further research is needed and to make it easier to compare different approaches. The first is localization and weather. Although LGPR doesn't rely on surface features, we found that when the ground gets very wet, like from rain or snow, its dielectric properties could change, and this could degrade the quality of the localization. For that reason, we include runs in the same location in clear weather, in snowy weather, and in rain. And this will allow us to benchmark and compare different approaches to ensuring that we can localize in any weather. The next benchmark is about multi-lane mapping. You see, cameras and LiDARs, they get a view of the entire scene from one location. But the LGPR sensor only records the underground topology that's directly beneath the car. Therefore, to map multiple lanes in a single road, we have to drive the vehicle down each lane separately and then stitch those lanes together to make a unified map. To that end, we include runs in the dataset where the car was driven in the right lane, in the left lane, and in the center lane. And you could use those to build a map. And then we also include runs where the car is changing lanes, so we could test that it can localize in that unified, stitched together map. To summarize, LGPR is a promising new modality for vehicle localization, and we're releasing Grounded, which is a large dataset to enable new research in this area. We also outlined two benchmarks to compare progress in particularly challenging areas in this space. So if you're excited about LGPR and you want to get involved, go to lgprdata.com where you can download the dataset. And if you have any questions, feel free to reach out, teddy@mit.edu. Thank you.